Good morning, class. So yesterday we spoke about the derivation of the sine compound angles, which is sine alpha plus beta, the sine alpha minus beta, and how they derive the formula for cos of alpha plus beta. As I've indicated in that lesson, which is basically wasn't recorded because I have load shedding at the time, but I will do it probably during this lesson as well. The derivation for the cos alpha plus beta compound angle. So at this point we were exposed to it. We spoke about the different identities that we were exposed to. We spoke about all of these rules here that's coming from grade 10, grade 10 and grade 11. So the compound angle identities are given there. We're looking at the examples for exercise 2, and this on page 95. The examples, which is example 1, let's put here. Example 1, and this is on page 94. Example 1 is on page 94. So just to refresh your memory at this point, I'm going to keep it on the side here. We got that cos of alpha plus beta can be written as cos alpha cos beta minus sine alpha sine beta. Correct? And if that is minus, then this is plus. Okay. Then we also spoke about the sine compound angle. We know that sine alpha plus beta is equal to sine alpha cos beta plus sine beta cos alpha, or cos alpha sine beta, and if that is minus, that is minus. Okay, so let me pull this over quickly. So I think that is behind that one box there. Okay, so that is what you should be exposed to from the previous lesson. Okay, well that is what I exposed you to in the previous lesson. Okay. So with that in mind, we are told on page 90, 95, 94, the question says the compound angle formula are used to simplify the following example. Simplify the expression. So if you look at number 1, we got sine 20 cos 40 plus cos 20 sine 40. Okay. So what do we notice here? What do we notice? She says many things. Yes, nice. But what you should notice is that on alpha's place, what do I have? Okay, this is, you see, this is cos sine, cos sine. So firstly, is that the cos rule or the sine rule? The sine. Why? Because I sine cos, cos sine. Not so. So that is how I know it belongs to the sine expansion. Can you see that, people? So what we do is we say, okay, on alpha's place, what do we have? We have 20. So there's also 20. Not so. What's at beta's place? 40. Can you see that, people? So in other words, alpha, since there's a plus there, is going to be 20 plus 40. Can you see that, people? I'll just show you again. As we can see that this can be written as sine alpha cos beta plus cos alpha cos alpha sine beta. Can you see that, people? And sine alpha cos beta plus cos alpha sine beta is going to be sine alpha plus beta. Okay, you guys understand? So if I take that into account, sine 20 cos 40 plus cos 20 sine 40 can simply be written as sine of 20 plus 40. And what is 20 plus 40? 60. Now sine of 60, 60 is a special angle, not a special triangle. So we draw the special triangle there, so that's 31 to root 3. And your 60 angle lies there. Sine of 60 is opposite over hypotenuse, so it's going to be the root of 3 over. Okay. So any confusion there? So do it again. No? Okay. Let's carry on. Whoops. This is still part of the example on page 94. Let's pull this down here. So what do we see here? Let's put this rather at the bottom. Here we got cos 50, cos 140 degrees. Then we have minus sine 130, sine 220 degrees. Can I go straight into this formula and identifying alpha and beta in this case? No. Why? So if that is alpha, that is an obtuse angle, that's obtuse, and that is a reflex. All the angles has to be acute when we do this calculation, okay? So sometimes it's a negative that comes out and so on and so on. You guys understand? So the first step is to get the angles into acute angles. Not so. So let's go. It's going to become cos of 50. So cos of 140 is in which quadrant? 140 is in the second quadrant. Are we getting to the second quadrant? 180 degrees minus. So that is all stations to Claremont. So 180 minus 40 degrees. Minus. Now when I move over to the next term, okay, what I look for there is, or what I'm going to change it to is angles dealing with 40 and 50 degrees. Does it make sense? There has to be angles dealing with 40 and 50. Why? So that I can link this first term with the second term. You guys understand? So let's go. 130 degrees in which quadrant? Second quadrant. How are we getting the second quadrant? 180 minus 50 degrees times sine of 220 is in which quadrant? Third quadrant. So it's going to become sine of 180 plus 40 degrees. Okay. So any confusion? No. Okay. So what I'm going to do now is I'm going to reduce that using reduction formula. So that's going to become cos of 50. 180 minus is cos positive and negative in the second quadrant. It's negative. So it's going to be negative cos 40. Can you see that, people? Minus 180 minus which quadrant is that in? Second quadrant. Beside positive and negative? Positive. Not so? So it's become sine of 50 degrees times 180 plus which quadrant is that in? Third quadrant. Sine positive and negative. Now that negative coming from here times this negative will become a positive. Positive sine 40 degrees. So what do we see now? Cos, cos, sine, sine. Not so? But what do you notice about this here compared to the formula that we have here? What do we notice? Sorry? There's a negative in front. Are you worried about that?
Why?
Because our here is positive. Can you see? So that negative should worry you. Not so? So how do I get the, what do I do with that negative? Factorize that negative. By factorizing that negative, what would I be left with? Cos 50, cos 40, minus sine 50, times sine 40. Okay? So what do I see now? Now I see cos alpha cos beta minus sine alpha sine beta. Can you see that, people? What is in alpha's place? 50 and 40. Not so? That's 50 and 40. So what? So it's the one dealing with minus, so I must go with the plus. So this is going to be 50 plus 40. You guys see that? Once I got it in that form, I can then move over and convert it to the compound angle. Okay? Does it make sense, people? Alright, so let's go. So that is going to be minus on the outside. It now is going to become cos of alpha plus beta. So it's going to be 50 degrees plus 40 degrees. And what is 50 degrees plus 40 degrees? 90. Okay? Let's pull this down. So it's going to be negative cos of 90 degrees. And then we take that to the cos graph. What is cos of 90? What's cos of 90, people? 0. The negative 0 is a 0. Okay? You guys understand? Let's carry on. This is also part of. There's too much on the board here. Too much information. Huh? Am I moving too fast? Okay. People, number 3 of example 1 on page 94. We got cos of 3a, cos of a plus sine of 3a, sine of a. What does that remind you of? You see, if you can't see it, okay, you can't see it. What I do is I say, okay, you've got cos, and that 3a is alpha. Let's make it alpha, then that will also be alpha. Not so? And then a, we make it beta and beta. So in our mind's eye, we see cos alpha, cos beta, sine alpha, sine beta. So what does that remind us of? Cos, cos, sine, sine. It is the cos rule. You see that, people? Cos, cos, sine, sine is the cos rule. And if here's a plus, then here must go away? Minus. You guys see that? So, let's go with that. So we said it's going to be cos alpha, cos beta, plus, so it's going to become cos, and the minus. Alpha is 3a minus beta, which is a. It's going to give us cos of 2a. Okay. You guys understand? Any confusion? No? It's fairly simple. Of this example, number 4, on page 94. Pull that roll up. Okay, example 1 on page 94, number 4. Okay. Here we are told in these work examples you will expand the compound angle formula. So now the question says show that. So this is what we call out as our identities, not so. So what do we do with identities? We work with the left hand side and we try to equal to the right hand side. We work with the right hand side equal to the left hand side. At times we're going to work with both, as you know. You know, we need a lot of this in grade 11. Right. So the question says show that that is equal to that thing. Okay. So which side do you think we're going to work with? Which side do you think is more complex? The left hand side. Okay. So we go left hand side. Now if you look at sine A plus B, sine of A plus B, that can be written as what? Sine of A plus B. Here we go. Sine A plus B can be written as sine A cos B. Then plus or minus, plus the sign of the sine will be the same. If you got cos, it will be cos cos, and the sign will be opposite. As I look here, this is cos, cos cos, opposite sign. You see that? You see if the ratios are the same, the sign is opposite. Over here the ratios are different, so the sign is the same. Can you see that? That's how I remember it. Okay? So this right is neater. So that is going to become sine of A cos of B plus sine of B cos of A, or cos of A sine of B, the same. So that is that. Why am I putting it in a bracket? Because there is a multiplication sign between. Can you see that, people? Now sine of A minus B can be written as what? Sine of A cos of B minus sine of B cos of A. So what do I notice now? What do I notice now? The conjugate pair. So what can I do here? What can I do here? Multiply the first and the last. Remember, if you got x minus y times x plus y, that is simply x squared minus y squared. Can you see that? That's a conjugate pair. So what do we do here? We're resulting in the difference of two squares. Here you're going to go sine A cos B times sine A cos B is sine squared A cos squared B minus sine squared B cos squared A. But if you look here, what do we have? We don't have cos, we have no causes. Not so. But what is cos squared B also equal to? Cos squared B plus sine squared B is equal to 1. So cos squared B is also the same as 1 minus sine squared B. You guys see that? Okay? So with that in mind, now I'm going to say that it's going to become sine squared A into 1 minus sine squared B minus sine squared B. Now cos squared A can be written as what? 1 minus sine squared A. Remember, the angles must be the same. Not so. We know that sine squared A plus cos squared A is 1. So cos squared A is equal to 1 minus sine squared A. So that's going to give you 1 minus sine squared A. So what do I do now? We get rid of the brackets, we multiply this out. Okay? So it's going to become sine squared A minus sine squared A, sine squared B minus sine squared B plus sine squared B sine squared A. Okay? So what do I notice now? We all agree that sine squared A sine squared B is the same as sine squared B sine squared A. So that cancels. So that is simply equal to sine squared A minus sine squared B. But what you also notice now, it is equal to the right hand side. Okay? it. Run through it again. See here? So what we do is we say, okay, the left hand side is more complex. So we expand. We're going to expand. Remember, expansion is easier than reduction. Like products is easier than, what's the reverse of products? Factorization, not so. So it's going to be easier to multiply out than to factorize. We'll work your way back. So it is possible to work with your right hand side. Okay, but it's going to be a bit more complex. It's easier the other way around. So what we do is we expand sine A plus B, becomes sine A cos B plus sine B cos A, must be multiplied. Why? Because there is multiplication sign between it. Sine A minus B can be written as sine A cos B minus sine B cos A. As you can notice, the conjugate pair, so I multiply the first and the last. So sine A cos B times sine A cos B, sine squared A cos squared B minus sine squared B cos squared A. And if we compare now to your the right hand side, we notice there was no coses. We replace cos squared B with 1 minus sine squared B, and cos squared A with 1 minus sine squared A. We get rid of the brackets, we add like terms, and lo and behold, it's equal to the right hand side. Okay. This video is fairly long now. Not my intention. Okay. The last of example 1 on page 94. Let's pull this up. Oops. People, this work is never going to be really understood by seeing somebody else do this work. Okay? You would have to do the work. Okay? Number 5. We are told that find the value of sine 75 without the use of a calculator. Sine of 75 without the use of a calculator. So looking at this here, what is, if it first gives you angles and it says without the use of a calculator, what comes to mind? Let's say without the use of a calculator, what comes to mind? Special angles, not so, or the graph. When it comes to 0, 90, 180, 270, 360, the graph comes to mind. Okay, or if it's in this case, they're talking about your special angles. And what are the special angles? The special angle triangles. It's going to be 30, 60, 1, 2, root 3, and 45, 1, 1, root 2. And the one that is not a triangle, I know it's not a triangle, but it works for what we're looking at here. This is 0, 1, 1. Okay. Those are the special angles. So, how can you link 75 to any of those special angles? How can you link that to any of the special angles? $75? 45, yes, you want to break it up, she says. Break it up into what? Sine of 30 plus 45, she says. You would agree with that? Or 45 plus 30. Not so? So, looking at that, now we see we've got special angles. So now we've got sine of alpha plus beta. Not so? So if it's sine alpha plus beta, in its place we've got 30 plus 45. So that will be sine 30 cos 45 plus sine 45 cos 30. You see that, people? So let's put that, write that down. So that would simply give us sine alpha cos beta plus sine beta cos alpha. So sine of 30, sine is 1 over 2. Cos of 45, Cos is adjacent of hypotenuse, is 1 over root 2 plus sine 45. Sinus, opposite of hypotenuse, is 1 over root 2 times cos of 30. Cos is adjacent of hypotenuse, which is root 3 over 2. Can you see that, people? So what does that now give us? Let's simplify our terms first. So that's going to give you 1 over 2 root 2 plus root 3 over 2 root 2. And that is 1 plus the root of 3 over 2 root 2. Okay. You can rationalize the denominator, but I wouldn't, because this deals with paper 2, whereas paper 1 normally would ask you to rationalize the denominator. But if you had punched this in the calculator, that there, at this point in the calculator, you would have gotten root 2 plus the root of 6 over 4. I think that would be your equivalent term. Okay. But at this point here, you get your full marks already. Okay. When they have out your calculator, they expect you not to put sine 75 in the calculator and get the answer. That's what they refer to. You guys understand? See any confusion here? So with that, you should be able to do exercise 2.